much. It's lovely to be here with you, and thank you so much for having me. I've got to say, I've really enjoyed watching the presentations this morning. I've learned a lot, which is, thank you. It's great to be here. So I'm just going to give you a little bit of my background. I'm over here in the UK with Too Simple, and I'm the product manager here. So I look after our whole product range, from Purple Mash, am I allowed to say it, through to Python in Pieces and all the other products that we do.
You're definitely allowed to say it, yes. You cannot go through your whole presentation making squigglies on the screen.
Yes. Too Simple is well known around the world. We're in 74 countries, 8,000 schools, I think, now worldwide, and over 200 of those are in South Africa. So we're really well known. And I work very closely with our team in South Africa, who are representing us here at this event, and I'm just really honoured to speak here. So I'm really excited to talk to you about Python in Pieces, and how you can use that to supercharge the teaching and learning of coding and robotics in your school. At Too Simple, we believe in teaching transferable skills, and we believe that if you teach children coding, then they can apply that to, if they go into any technology industry, whether that's web development, developing web apps, or even robotics, they can use those skills and transfer them to those industries. And I just want to now go into talking about why we made Python in Pieces. So in the previous talk from Karen, we heard some really worrying statistics, I suppose, about the uptake of computing in universities. And that isn't just, there in South Africa. We had the same thing over here in the UK. And we did our research before we actually made Python in Pieces. We found that in 2018, we had our equivalent senior phase, the overall number of computing qualifications taken by students had decreased by 45% in a year. We'd also seen the reduction of lesson time for our computing curriculum. It was reduced from 1 hour a week down to 45 minutes a week. And that was really scary. Like, why aren't people moving into technology and taking up computing? And in our research, we also found that only 36% of computing teachers in our equivalent senior phase were actually computer science graduates, which was a scary statistic. And it's quite simple. We've got history graduates and geography graduates teaching children in senior phase, into further education, computing. And that just seemed really scary to us. Also in our research, we looked at, what's the most popular language out there to teach at our equivalent senior phase. And that was Python. There was a shift to Python. 21% of schools in our research were actually teaching Python. It came out the most popular. So why Python? Why is that the most popular thing to be starting with? I'm going to answer that question, but first I'm going to ask you guys out there, the audience, a question. Now, I wonder if any of you can just answer in chat. Our team will look at the chat, and at the end, I'll actually give the answer. But why is Python called Python? And please don't just Google that now. If you don't know the answer, don't answer it. But why? Why is it called Python? So that's the question I'm asking you guys, and I'll answer that at the end. But why Python? Why is it taught in schools? Why did 21% of schools teach Python as opposed to Java or C++? Well, Python's much more concise. It's a much more expressive language, and it teaches basic syntax. It has very simple code readability and English-like commands. So it's much easier to teach it and then to transfer the things that they've learned into other languages as well. And Python is it's a scripting language. It's used for web applications. It's used for pages within a web browser, operating shells, even games. Even the Google search engine uses Python. So it is a transferable language that's used within our industry as developers. So I'm now going to share my screen and actually show you Python in Pieces. Can you just confirm that you can see my screen? Has it shared?
It is clear and I can see it.
Lovely, thank you. So Python in Pieces attempts to solve some of those problems that I'd mentioned previously. We have got in here, so I'm going to just show our resources. We've got a number of lessons which teach very discrete skills, whether that's text output, calculations, step by step. And as teachers, you can see children's progress in what we have as a data dashboard, which shows you every single student, where they are in each lesson, which stage they're on, and how much help they actually needed. And throughout the actual lessons, we provide videos and instruction on what it is that you're actually doing. We provide really clear success criteria. And then at the end of each lesson, there is a consolidation, which allows the children to make something, to use the skills which they've learned and actually make something. We also provide for our non-specialists all the solutions, all the answers to these lessons, so that you guys are just not going to get stuck. It is built for the non-specialist, someone with no prior experience. Overall, there's more than 170 videos guiding you through that content. But I'm going to show you the backbone of what makes Python in Pieces really special. We have free code projects, and we have microbit projects. So it links with the microbit, so you can use the microbits here and make it flash and link it up to a robot and control that robot. I'll show you some examples of that. We can set tasks for students. And this here is our coding environment. Now, this is particularly special. You may have seen other coding environments before, but probably nothing quite like this. For example, I can drag things in, and it includes the Python code on the left. Where Python in Pieces is different is it allows you to actually do that in reverse. So if I start to type in here, I can actually see the blocks being created on the other side of my screen. Now, that two-way translation really helps scaffold learning. And I'm just going to show you some examples of the types of things that our students create. So actually, I'll show you something that I created. This was the very first thing that I created in Python in Pieces. And again, something really unique about Python in Pieces is that we have this whole design mode. Now, this design mode allows you to take what is a text-based coding language of Python and do something visual, make it exciting, makes things move on the screen. So here I've just got a very simple script that when I click on the kid, he starts skating. And very quickly we can start to move that into much more advanced things. So here's a game with 142 lines of code, which is, you know, a catching game. It's a bit like Space Invaders. You can make Space Invaders in this. The other thing, just to show you the microbit, I'll show you my joke book that I made. It imports the microbit libraries for the Python, but then we actually have a simulation of the microbit here. So even if you don't have the physical microbits, and these are really cheap, you can actually use the simulator.
James, just so you're aware, we've hit time, but happy to give you another minute because this is pretty darn cool.
You're awesome. Thank you for that. I really, really appreciate it. So yeah, you can actually simulate using the microbit here. We also have recently released example libraries in our showcase. Now, this allows your students to share their code and the things that they've created with all our users of Python in Pieces around the world. And then they can view other children's code and learn from that as well. I'm not going to go into anything really, any more things on Python, because we've got Ingrid from Glenwood House later actually showing more of this in more detail. But if you want to learn more, you know, speak to our team, and yeah, they will happily help you. And finally, back to that question. The answer, and our team will pick out a winner. You can win a year license to Python in Pieces. So when Guido van Rossum was creating the language of Python and implemented it, he was reading the scripts of Monty Python's Flying Circus. And from that, he took the name Python because it was mysterious and cool. And that's where the name Python actually comes from. And I just want to say once again, thank you for having me. I feel really honored to be here.